We're going to go ahead and take a look at geometric sequences in series. With a geometric sequence, that's just a list of numbers like we have down here. Remember, a sequence is a list of numbers. A series is when you're adding again, where you end up multiplying by the same number each time. So you'll notice down here, 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. That number you're multiplying by is r. That's referred to as your common ratio. Now, if you didn't see that you're multiplying by 3 each time, you could always take one term divided by the previous term. That helps you find r. Or you could have taken the third term divided by the second term. And in each case, you end up getting 3. So that's what you're multiplying by. Now, in our formula up here, what you're multiplying by is r. Now, this is still your first term, and then n is the number of terms. So if we go ahead and look down below here, we need to state if it's an arithmetic sequence. So as we look here, so all we have to do to see if this is an geometric sequence is to take one term divided by the previous term. And in this case, we would get 6. But we should check to see if that works for the other ones also. So take the negative 72 divided by the negative 12, you also get 6. So yes, it is geometric because we're multiplying by the same number each time of 6. Now here we need to find the next 3 terms. Well, first of all, you got to figure out r, so you can always go one term divided by the previous term, and in this case we get 1/2. Now, that also works if we would take the fourth term divided by the third term. Take one term divided by the previous term, you get 1/2. So it means we're multiplying by 1/2 each time. We can take our negative 2, multiply it by 1/2, and we get negative 1. Take negative 1 times 1/2, we get 1/2 negative. Take negative 1/2 times 1/2, we get negative 1/4. When we're looking at the one down below, you have your first term, and you're asked to find the first 5 terms. Well, we have r, that's what we're multiplying by, so you got to multiply by negative 2. So negative 1 and 1/2 times negative 2 is 3. Multiply by negative 2, you get negative 6. Multiply by negative 2, you get positive 12. Multiply by negative 2, you get negative 24. Now here we need to find our 9th term. Now could we list this out for 9 times? Yes, but we could use our formula. We have our first term right here, which goes in for here. We have r, which goes in for r right here, and then that's your n. And so if we plug that into our formula, we would plug in our n, plug in our r, plug in our first term. Then we could type it in just as you see it. You may want to go ahead and just simplify your exponent to just an 8 before you type it in. And then when you type that in, you will get negative 768. We want to go ahead and do the same thing for problem number 31 here. But 31, you're not given r. Well, we figured out r before. Remember, you can go one term divided by the previous term, and that is 3. So now it's just like your last term. We can plug in our first term, which is negative 1, plug in our r that we just figured out of 3, and we are trying to figure out what it is for our 11th term. Plug in 11 minus 1. Well, for your exponent, you might want to just simplify that. 11 minus 1, you know, is 10. Now, just type all this into your calculator just as you see it, and you get negative 59,049. So now we need to write that explicit formula. Remember your explicit formula, you need to leave it with an n. So all we have to do is go a sub n, plug in our first term, plug in r. Remember you got to leave it with an n. Our first term, once again, is 4. Our r, once again, is negative 6. Well, this is your explicit formula. Now, in the last section, we had arithmetic means. That's pretty much means you're trying to find the numbers that go in between that form an arithmetic sequence. Similarly here, we have geometric means, where you're trying to find the numbers in between so that it ends up being a geometric sequence. So with this in mind, you would know that this would be your first term. This would be your second, third, fourth, fifth. This would be your sixth term. Now, we know our first term, we know our sixth term, but we don't know what we're multiplying by. We know we're multiplying by r. So we can use our formula over here, plugging in everything that we know to help us find what it is we are looking for. We're going to go ahead and plug in our last term, which is that negative 1024. We're going to go ahead and plug in our first term, which we know right here, of negative 1. We don't know what r is. That's what we're multiplying by. But we do know that for this last term, it's our sixth term, we're going to plug that in for n. So to be able to solve this, I need to get rid of timesing by negative 1. I'm going to divide both sides by negative 1, so I get 1024 is equal to r. And well, I'm going to simplify my exponent. 6 minus 1 we know is 5. So now to get r, I need to take the fifth root of 1024. So if you're doing this on your calculator, you'd want to go 5, then you'd want to hit your X root button, and then you'd want to type in 1024 in your root. And when you do that, you end up getting r to be 4. If r is 4, that means you're multiplying by 4 each time. So all we have to do is go back up here and start multiplying by 4. Negative 1 times 4, you know, is negative 4. Then negative 4 times our r of 4 is negative 16. Once again, r is 4. We multiply by 4 again, we get negative 64. Multiply by r again, we get negative 256. By the way, we can double check that we did this right, because if you take your negative 256 and multiply it by 4, you do get to that negative 1024.